Hi class, this is Neil, and this is the third video for lesson 10. I lied a little bit and said that this would be a 2-video lesson, but I wanted to make the videos a little bit shorter, so we're going to do a third video for examples 2 and 3. All right, so this example, if you want to know where it comes from in the unit, it's from lesson 2 of unit 8. And in that lesson, we really looked at solving for rate. Okay, so Eddie buys an old gaming system for $60 and ends up modding the system to have a variety of games. In 8 years, he sells it for $650. Assuming exponential growth, determine the annual appreciation rate to the nearest tenth of a percent. Okay, so we're going to be using our exponential growth equation for this. There's nothing compounding. It's just a regular old exponential growth equation. And let's talk about what we know. Well, we know he bought the system for $60. We know that he sold it for $650, so it ended up at that cost. And we know that he sold it 8 years after he bought it. What we don't know here is our rate, and so that's what we're solving for. Okay, so I'm going to plug in what I know. So I know 650 is equal to 60 times 1 plus r raised to the power of 8. So what I really need to get by itself is this r. To do that, the first thing I'm going to do is divide both sides by 60. Okay, I need a calculator to do that probably. You could do it by hand, take a little longer. 60s cancel over here. So I go to Desmos 650 divided by 60. You get 10.83 repeating. So 10.83 repeating really. Could write a few more 3s. Equals 1 plus r raised to the power of 8. Okay, so we need to undo that exponent of 8. To do that, we take the 8th root of both sides. So on the right side of the equation, that's going to cancel out our exponent, and we're left with 1 plus r. I can't do this by hand, so I'm going to have to go to a calculator. I'll use Desmos. Now, on the sort of iPad or iPhone or smartphone version of Desmos, you find that feature, the 8th root, in functions. And that's what it looks like. So we're finding the 8th root of 10.8333. And we get 1.3469307 if I round that. So we'll come back here. Okay, we're almost there. To solve for r, I would subtract 1 from both sides. Oh, that's my brother telling me he started to bake bread again. Cancels there. So r equals 0.34 0.3469307. And now we're asked to write that rate to the nearest tenth of a percent. So let's first change this into a percent. So r equals 34.693. So we're rounding to the nearest tenth. Tenths are here. So that would be 34 0.7%. So that's the rate. Okay, you can pause the video if you need to get that down. But let's move into the last example. And this is an example that is what we just did in Unit 8, Lesson 8. So example 3. A study of rats in New York City reveals that their population can be represented by the function R of t equals 1,230,210 times 1.014 raised to the power of t, where t is the number of years since the study began. Which function is correctly rewritten to reveal the monthly growth rate of the New York City rat population? All right, so here we are going from a yearly rate to a monthly rate. So we're getting smaller. To do that, I would need to raise my rate to the 1/12th power. So we'll take that 1.014, we'll raise it to the power of 1/12. And when I do that, go to my calculator. Let me just kind of write that that's the rate. And I do get 1.00159. Right, so 1.001159. All right, now that automatically then I can eliminate choice 3 and 4 because the rate doesn't match up. Now, thinking about the exponent, again, we're going from years to months. So it was in terms of t years, changing that to months, I'd have to multiply my years by 12. So my exponent needs to be 12t. Right? I can eliminate choice 1. Choice 2 is the correct answer. So that is the last example in this lesson. Your classwork and homework really is to complete questions 1 through 6. All right. And I will talk to you all soon.